Sometimes you say good morning, people, but yeah, good evening, guys. All right, let's what do we got? Differentiation 4. The next part of differentiation. How are you going, Zoe? Welcome. If you guys have sent me some questions on email, just let me know. Complex numbers. I've got a complex numbers question for level 3, but I don't really have any differentiation questions yet. Hey Marco, hey Mal. Aswin, is it Aswin? Oh, I got one. Oh, that's an integration question. It's not a differentiation question. Level 3 differentiation question. All right, I think we have an old question here. We might actually do this question because it looks very interesting. Very crazy, but interesting. Sorry, I was just looking at past emails just to see if there's any questions that's actually popping up. Just waiting for this to sync up, guys, and then we can get started. Here we go. Don't know how good this is on screen, but I think, speak of optimization, this is optimization. Tech Gaming Smart. All right, so this is actually one of those really annoyingly easy excellence questions. But anyway, let's try and actually work this out. Volume of this is pi a4 rate of change. Rate of change, yeah, sure, Mel. Pi a4 2. I don't understand what's the point of actually giving the paraboloid the same top surface is in the diagram below. Nah, sweet ass. All right, look, let's try and go through this question. All right, now look, I'm just looking at this, like that whole paraboloid results with a volume of pi a4 over 2. Now I'm trying to understand what's the actual purpose of that volume, because we don't really need that from where I'm standing. I'm going to try and do this, and if I might be wrong, but it's all right, doesn't matter. So what I'm going to do is I'm going to sketch my I'm going to sketch the x-axis here. Now it says that the parabola, I'm going to draw a parabola first, which is x squared. Now the next thing is, what do we have? We have A is the maximum distance for this. Okay, so A goes from there to there. Okay, so what I'm going to do is I'm going to kind of stop this parabola at about here. So this distance is A, this distance is A squared. Now, remember I talked about looking at the 3D shape as a 2D shape. So if I was to take a, I need a different colored pen. So I'm going to take this cylinder right here. Sorry, that should have gone up there. Maybe up to there. There's my cylinder. So if I look at this green cylinder right now, a couple of things to notice is the radius is from there to there. So that's just going to be x, right? Because if it's x, then the radius is equal to x. Then what I have is I've actually got this height of the cylinder. The height of the cylinder is equal to a squared minus this distance. So if you look at the height is the green part here, and then this blue part, sorry, let me just try that again. The h is the green part, the blue part we need to actually figure out. And then, so we can kind of say that the yellow part minus the blue part is equal to the green part, the height. But if you look at it, this is a parabola, and if it's x, then this distance here from here to here is going to be x squared because it's on the parabola itself. Ah, Sam, what happened? You didn't do maths in year 13? Or did you get excellence in level 3 in last year and let me not do maths? Oh, right. So you've actually done it already as a year 12. Okay. That's good to know. That's good to know. So I hope you guys can see what I've done there, right? So all I've done is I've got the height now. So the height of this cylinder is going to be the yellow part minus the blue part, which means the height of the cylinder is equal to a squared minus x squared. That's the height. So now we've got volume of a cylinder. Volume of a cylinder is equal to pi r squared times h. So r squared, r we know happens to be x, so that's going to be x squared. And then h is equal to a squared minus x squared. So we expand this, we're going to get pi a squared x squared, and then pi minus pi x to the power of 4. So this basically shows what the equation for volume of cylinder is. Now we got to figure out what the maximum volume of the cylinder is. So we're going to differentiate it. So when we differentiate it, we get 2 pi a squared x minus 4 pi x cubed. And what we're going to do is we're actually going to put that equal to 0, because when we put the volume is equal to 0, we're going to find maximum minimum. And so we're going to have 0 is equal to 2 pi a squared x minus 4 pi x cubed. then what we can do is we can kind of get rid of a few things. So I'm going to take 2 pi x as a common factor, which means I've got a squared minus 2x squared. I think that's correct. Let me just check. 2 pi x. Yep, that's all looking good. And then from here, I could say that 2 pi x is equal to 0, which means x is equal to 0. Or a squared minus 2x squared is equal to 0. So I'm going to get a squared is equal to 2x squared. And then I'm just going to rewrite it like this. 2x squared equals a squared. X squared is equal to a squared over 2. X is equal to square root of a squared over 2. So x is equal to a over square root of 2. Now it's asking us to find the maximum volume. So volume equation is equal to pi a squared x squared minus pi x to the power of 4. So we're going to get pi a squared a over square root of 2 squared minus pi a over square root of 2 to the power of 4. So we're going to get pi a squared times a squared over 2 minus pi a to the power of 4 divided by square root of 2 to the power of 4 is going to be just 4. And then from here, we've actually got pi a to the power of 4, no, over 2, sorry, minus pi a 4 over 4. We're going to multiply this by 2, so we have the same denominator, and we're going to get 2 pi a to the power of 4 over 4 minus pi a4 over 4, and then this is going to give us the final answer of pi a to the power of 4 divided by 4. Right, so what I'll do is, as always, put a series of line numbers. I can see there's a couple of questions popping up. Sumit, thank you, Marco, for answering that question. Appreciate it. Why use x squared as the height of the parabola? Okay, let's think about it like this. If you have a parabola, and this is something you guys would have seen in level 2, right? Like, because this is y equals to x squared, if I take any point here, if this point here on the x value is 3, then along the y value, you're going to get 3 squared, which is equal to 9. So, but the cylinder is actually above that point, right? So if you think about it like this, the cylinder is kind of like that. So it's actually above that 3 squared. So when I actually write this as, so for example, if I write this line as 4, then this would be 4 squared, which is equal to 16. But because I'm using x, because I don't know what that is, it's going to be x squared. So the x squared distance is from there to there, but the height of the cylinder is actually above that point. Therefore, I need to go a squared minus x squared. Let me just, okay, you guys have a look at that. I'll just try and show you guys how the demo actually works. Y is equal to x squared, x equals to a, y equals to x squared. I want a line that goes y is equal to from negative square root of x, negative square root of a Okay. Oh, you got it. Okay, sweet as. Because the other way I was going to show you guys was through this here. So if you look at it, the height, so let me just work this out. Hold on, 2.122. So x is equal to square root of a, and that's going to be between it's going to be y less than a. So y is less than or equal to a between 0. Okay, here you go. Now the cylinder is, we want it between, I might actually do this. Give me 1 second, guys. Less than, equal to, no, greater than equal to. I'm gonna maybe cap it off at 10. Yeah. So hopefully you guys can see what's happening here, right? Like that blue line is the height. Sorry, the height of the cylinder is actually here, but because our parabola is only going up to a, so if I go all the way to the end there, this distance here is going to be, if this is a from here to here, this is going to be a squared. But as we go down, if we want the height of the cylinder, we know that this distance is a squared, but this value here is x, so the blue line would be x squared. So then we do a squared minus x squared, and we actually get the height of the cylinder. No, unfortunately, no, Mel, I don't do that. Cool. Any other questions, guys, with this excellence question? I don't know who sent this. Who was it? I might just reply. Someone sent it to me on September 6th. Did this in today's tutorial. All right. Cool. That's done. I'm just checking. Nobody else sent me any other questions? No. Let's see what else is there. Differentiation question. This is an integration question. Huh. Oh wow. Okay, now these are all the exam papers. Okay, that's not going to help me. Do you have any tips and tricks for the shapes inside shape? Excellent question. I really struggle at them. Sumit, I think like it's all about finding the right formula, and I think once you find the right formula, then you're pretty much good to go. So it just comes with practice. That's all. Differentiation zip file. I don't know what this is. Oh, these are all exam questions. Damn it. Differentiation. No, I've got. Sorry guys, I've actually got no more questions. But like 2018 2E. Okay, let's try that one. Okay. Speaking about that, Stacy, I haven't actually repackaged it, but I'll look at that. Mel, we're gonna do that question next. But I just want to show Stacy this. So I need to kind of like repackage it, but back in the day when I was teaching calculus to my class, there is a hidden playlist here. Where is it? See, that's the problem. It's actually hidden. Proper hidden, is it? I can't even find it. Oh, here. Was it this one? Yeah, this one here. Here we go. So this is what I did for my class back in 2017. I mean, like it covers basically all the kind of like the essential skills that you need to know for all three standards. So it's like a good set of revision, like in a sense where like I think if I go to like week 3, for example, oh my god, we're watching ads inside ads. How terrible is that? Yeah, so what I did was like I basically went through like 2 or 3 questions like this, which covers all the basics that's necessary for yeah, for those 3 standards. So I think there's like 19, is it 19 videos? Yeah, 19 videos in it. Don't know why. There's about, yeah, 6 in complex numbers, 7 in differentiation, and then 6 more in integration. So I need to repackage it, but it's really good. It just covers all the essential skills that you need. I try and do as much as I can so that, like, you know, when I do product rule and quotient rule, we're actually doing trigonometric functions in it as well. So you're kind of doubling up on things. I'll repackage it sometime today or tomorrow so that I can put it properly so people can kind of keep an eye on it. All right. So let's have a look at the 2018 question 2E. 2018 question 2E. Okay, so what do we got? 2018 91578. Schedule. Oh, this one here. Mel, is this the rate of change question here? I think it is. Yeah, just waiting for it to load up, and then we can get started on it. Now, I wish I could say the same thing. There was good old days when I've been doing it for the last 10 years. All right, rate of change question. All right, folks. Did you guys want to have a go at it first? Maybe I'll give you guys a few minutes to have a go. How about you try that? One thing you're going to need for this definitely is you're going to need volume of a cone equation. So I'm going to grab that, and we're going to also need volume. We're also going to need surface area of a cone as well, by the looks of it. Calculus formula sheet. Where is my cone stuff? Cone surface area. Oh, unless I'm getting the wrong one, but is this surface area of just the water on top? It's just surface area of water on the top, which is not, it's not curved surface area. Yeah. We'll do this. All right, we'll do this. I think I've just trying to put this. I don't think you need curved surface area here, but it should pop up. Is equal to 125. We'll try, Stacy, because we're already halfway through. All right, so I'm going to start doing this question right now. With this question, you know, when they're talking about rate of change, you kind of know it's, you know, you got to do one of those DVDR, DVDT kind of things, right? Now the other thing also is that this is a like question E. Question E generally tends to be an excellence question, and if it's a rate of change question, I can tell you right now, you're gonna have to do like a what we call a triple. I call it the triple threat rate of change. because basically you're going to be doing three kind of equations, combine them to try and solve the equation. So the best way to do this is to actually write down all the things that you have, all the information that you have, and what you're going to do with it. Now, I'm going to be honest with you guys. The first thing I see in this question is I see volume. Okay, it's a three-dimensional shape, and I've got some water filling up in it, which means I have volume, and I've also got, what else do I have? I've actually got pi r squared h. There's only one issue that I'm finding with this. So volume of this is pi r squared h. Now I know that I need to actually differentiate this, and when I differentiate it, I can't differentiate this. This is like the first problem I see straight away, right? And most of these types of questions, when it comes to these triple threat rate of change questions, is that you have an extra element. What do I mean by that? Like, look at this. You've got radius and you've got height. Radius and height, they're both changing. And it depends on each other, right? Because if the radius changes here, if the radius goes big, then the height is also changing. So that's something that you guys need to remember. So they're dependent on each other, right? And I think, I don't know if Andrew, again, every day you ask me for the same thing, Marco. Can you just bookmark it? There. So what we need to do is, when I look at this volume for pi r squared h, I forgot a 1/3. Yeah, I have forgotten a 1/3. Doesn't matter. I still have to get rid of the r and the a or the h. But in this case, I'm actually going to get rid of the h. So what I'm going to do is I'm going to look at this three-dimensional shape as 2 dimensions. All right. When I do that, what I have here is I've got AT, which is the radius from here to here, and the height, which is 200 from here to here. What I need though is a relationship. So in other words, if this is the radius from here to here, then h is going to be from there to there, which is the height of the water itself. So what I can then do is I could write it as a radius, sorry, not a radius, ratio. So if I go r divided by h, I'm actually going to get the same thing as AT over 200. So with that in mind, but I actually want to put down what h is. So I'm going to flip it around. I'm going to write this as h over r is equal to 200 over AT, which means h is equal to 200 divided by AT, which is, what is 200 divided by? Like, you know, so it's like 2.5, is it? Brain is running slow today. Yeah, 2.5. So we got 2.5 h. No, r, sorry. Yes, Sumit, it's basically because it's similar triangles. That's pretty exactly what we're trying to do. We're just trying to show h in terms of r. All right. So once that's done, I can actually, like, I haven't even started differentiating yet, right? And I think this is something you guys need to understand when it comes to optimization and rate of change questions, is that before you even start differentiating, you need to make sure that when you differentiate, you have the same letters. You cannot have different letters. If you have different letters, figure out a way to get rid of one of the letters. All right. So what I'm going to do is I'm going to get rid of that h, and I've got volume is equal to pi r squared divided by 3 multiplied by h, which is 2.5 r. So my volume equation is now equal to, now 2.5 divided by 3, I'm going to do that. I don't like putting decimals in fractions, so I'm just going to click on that F to D, and I've got 5 over 6. So 5 over 6 pi r cubed. Name man guy, you know what? Like, since, are you actually from Queensland? Because I'd love to get my hands on some papers, man. I've got no idea where to look. So flick me over some of your exam papers. I'd love to try and do it just for the hell of it. All right, so questions so far with the volume. Who was it? Mel, any questions so far with what I've done? Because I think this is something that you have to do before you even start with the actual question. Just be aware of it. Anyway, so the next thing is this, right? Now this is just the first starting part that I've done. I think I just struggle finding how to get the letters only down to 1. Are you Mel, do you actually understand what's happened here so far? Okay, sweet. Yeah, I think this is the key thing, right? Like you always have to look at three-dimensional shapes in 2D version. And I think when you see that, you can kind of see what's happening. But the whole point is you want to get rid of that letter. Once you get rid of the letter, then it kind of starts making sense. Okay, so let's go have a look at the rest of the question now. The first thing to have a look at is we have this. The tank is being filled at centimeter cube per second. Now here's a clue, guys. This is where your clues come in, when they give you the units. All right, when you look at centimeter cube, you know that this is actually volume. And when you look at per second, this is actually time. So then we have our first kind of little thing here that we can do, which is dv dt equals 150, because that's centimeter cubed per second. Now the question is asking what rate will the surface area of the water be increasing? So the question is asking the rate, the surface area. Rate is dSA dt. So based on that, if we look at, this is what the question is asking us. What is dSA dt? They've given us dv dt. That's all they've given us. We have this equation here, which when we differentiate it, we're going to get dv dr. So we could potentially flip it upside down, which was going to give us dr dv like this, because that will actually cancel out the two dv's. Then what's remaining? So this is how I do it, right? I kind of go, okay, there's a dv there and a dv there. That's going to cancel out. There's a dt there. Well, I've got dt on the other side, so I don't want to mess around with the dt. I want to leave it there. I need a dSA on the numerator, because look, I need a dSA on the numerator. So I'm going to put that on the numerator. Plus, I need to get rid of the dr. So I need to have dr in the denominator of this one. So this is a standard way of coming up with this equation for any kind of triple threat questions, right? You kind of see what you've been given, what are you looking for, what are the things you need to find to eliminate it. This is always the case with triple threat questions. So we've got the formula for dv dr, because we can do that, because that's just 3 times 5 over 6 pi r squared, which is equal to 5 over 2 pi r squared. That's dv dr, which means I'm going to do dr dv now. Give me 1 second. I just want to move this down a bit more space. So then dr dv is equal to everything flipped upside down. So it's 2 over 5 pi r squared. Finally, the surface area of the water surface area is the top of the water. That's a circle. So we can actually say that's pi r squared. So dSA dr is going to be 2 pi r. So we've come up with this equation now. dv dt is 150. dr dv is 2 over 5 pi r squared multiplied by dSA dr, which is actually 2 pi r. So let's start canceling a few things out. Our pi cancels out. Then our 5 cancels out here with 30. So what we've got here is for 120. The r cancels out with this. We've got 120 over r. This is what dSA dt is, 120 over r. Now the question is asking when the depth of the water is 125. So if the depth of the water is 125, which is there, we told that if the height is equal to 2.5 r, h is 125 divided by 2.5 r is equal to 125 divided by 2.5, so r is equal to 50, which we can bring back here. So dSA over dt equals 120 divided by 50, which equals to 2.4 meters squared per second. All right, feel free to ask questions. TechSmart, confused on the surface area. Sorry, no worries. It is the question, if you look at the question right there, it is asking us for the surface area of the water. So when we look at the surface area of the water, that is the surface area, that the part that's actually colored in yellow. Now that shape is a circle. The area of a circle is pi r squared. Let me know if that's all right. Yeah, sweet name man guy. That'd be amazing, because I've been like, I don't know where to look for those papers, but yeah, like even if you just give me like a link or something like that, like something where I could find the questions and answers, I'd be kind of keen to do it. Yeah, so Mel, I think this is what I do with the triple threat rate of change questions. Like there's a lot of it in the past papers. And I know I've done a few of them. So if you just go and have a look at them, you will find that I use this method a lot. Like I kind of go, you know, what have we been given? What are we looking for? And then fill up that equation. I'm talking about this equation in the, I think this is the key part in the red box. Once you figure out the red box, everything else just falls into place really, really nicely. So it's just something that you just need to keep practicing, and then you'll get it, because they don't have that many shapes, right? Like, I mean, you've got like, it's just a repeat of the same shapes that they do. Why is the 125 centimeter given not r but h, not r but h? No, I think the one, that's the actual question itself, Stacy. They're asking how fast is the surface area increasing at that height. So they basically, they could have given you just that question. They could have actually given you r as 50, but they try to make you do one more extra step. That's all. So Stacy, they could have actually said, what's the surface area increasing when the radius is 50? But instead of saying radius, they just said when height is 125. That's all. They didn't, Joseph. I just cut and paste that surface area formula. That was my bad, because I thought we needed it before reading the question. Sure thing, Marco, sure. Centimeter squared, is it? Oh, did I make a mistake? Yeah, sorry, that should be centimeter squared. But I don't think you guys get penalized for units. So thanks, Stacy, for picking it up. How about finding r? Because we did our entire surface, like if you look at the surface area. Okay, have a look at this one, right? So we said dSA over dt is equal to 120 over r. But our relationship was that h was equal to 2.5 r. So r could be said as h divided by 2.5. And I mean, you can still do that here, right? Because you'll literally get the same answer, because if you go 120 divided by h divided by 2.5, and then height was 125. So if I go 120 divided by 125 over 0.5, sorry, 2.5, you're still going to get that same rate of 2.4. So let's try it out. So if I go 120 divided by 125 divided by 2.5, I'm still going to get that same 2.4. So it's just they're just making you do an extra step with that whole thing. That's all. H, let me just have a look at it, because if it's like what do we got? With a maximum point. Oh, this is actually a lovely question. I've not done this before. Nasty, but Jesus. H, that is one nasty question. That's all I can tell you. Oh my God. Was that in your mock exam, H? we could try H's question. It's super horrible, but I'm actually intrigued by wanting to do this. Okay, we're gonna do H's question because it's from the mock exams. It's a bit more recent. The diagram shows the graph. Prove that what the? Why would you even do that? Yeah, I think we might. What's the time? I think this question is going to take us a while. So let's give it a go, because I think it's a good challenge, this question. Man, what a nasty question. Sine squared x cos squared x cos squared. Oh, wow. What is happening here? I think just differentiating it itself is such a pain. You know what's frustrating is that I'll show you guys the answer, right? The answer is like, how are you even supposed to get, like, I feel for you guys even when you guys get the answers. Like, you look at the answers and you go, how the hell are you supposed to get this? I'm sitting here racking my brains. What do we got? Sine cube x cos x 3/2. Why do they go 3/2? It's really strange. Okay, so we've got a differentiator, but I'm trying to figure out what's the point of m, where with the maximum. Oh, so then you got to figure out tan squared k is equal to 6. So okay, so here's what we're gonna try and do, folks, because I've got no idea what's happening here, but like, we're gonna try and differentiate it first. Once we differentiate it, we're gonna once we differentiate it, we know that the maximum, when x is equal to k, the gradient is equal to 0. We know that much. When x equals to k, gradient is equal to 0. Okay, let's try it. I think we'll be all right. So what I'd like you guys to do first is try and differentiate it. Differentiate this. You've got a product rule happening here. just to be aware. So I would like you guys to differentiate this, and I'm going to write it slightly different for you guys, so just so that it helps you differentiate, because this is what I would do. Sine cube x, I would write it as sine x to the power of 3 multiplied by cos x to the power of half, because it is root square root of cos x. So I'm actually going to put that as cos x to the power of half. I'm fascinated how they've stuffed up the answer. Harman, I can't comment on that because I don't know what, you know, the way I see it always is that if you guys are in much more challenging situations, I would say, like, being in a hard situation right now and trying to understand how it works, it allows you to actually have these different kind of ideas going into the exam. So I think it's worth it. But even if you guys can get up to like the merit level, which would be differentiating it and then substituting x equals to k, you're on a good path. So I'll let you guys do this first, just the first part of it. See if you can differentiate this first. Once you differentiate it, know that f dash of k is equal to 0, because it's actually telling you when x is equal to k, there is a turning point, a maximum point, right? Which actually tells us the gradient is equal to 0 at k, because it has a flat line. So just give it a go. I mean, give it a go, a couple of minutes. Like, let's see how far you guys actually come up with it, and then we'll try and do that last part, because I think if you can get it up to that x equals to k and figure out what it is, I reckon you're pretty close to a merit at least. But H, it's a good question, H. Like, look, don't get me wrong. Like, I know some people are like, oh my god, it's horrible, but it's really good to do these types of questions before the exam, because you kind of get an idea of how different some of these questions get asked. Now I'm going to be honest with you guys, I'm looking at the answers here and I've got no idea how to do that last bit, so I'm going to kind of slowly work my way through and see if I can make sense. No. I can come in early. All right, look, let's give this a go, all right? I think you guys should be okay with this part of it, because this part of it, we're just using product rule. So what we're going to do is we're going to go u is equal to sine x cubed. So u dash is equal to 3 sine x squared multiplied by the differentiation of sine x, which happens to be cos x. Next, we've got v is equal to cos x to the power of half. Then v dash is equal to half times cos x to the power of negative half multiplied by the differentiation of cos x, which is negative sine x. Now all of this part is, you guys should be able to do. I know, I hear you, Abysm, I hear you. It looks traumatizing. That's something, let's get that out of the way. It looks traumatizing, but we should be able to do it. Okay, so what we're now going to do is we're going to put f dash of x as u dash v plus uv dash. So u dash is 3 sine x squared cos x multiplied by v, which happens to be cos x to the power of half, plus u, which happens to be sine x to the power of 3, times v dash, which happens to be half cos x to the power of negative half multiplied by negative sine x. Hopefully I'm on the right track here. The next thing is I'm just going to kind of tidy this up a little bit. So I've got 3 sine x squared. Now cos x has a power of 1 here. 1 plus a half is 1.5 or 3 over 2. So I'm going to write this as cos x 3 over 2. This will become minus sine x to the power of 4 times half cos x to the power of negative half. I'm going to pause there just to ask you guys if there's any questions before carrying on. Three sine squared x cos k minus sine. Yep. That's all good. Harder. You get merit for just correct dy dx. Wow, that's so just this you're getting a merit. That's crazy. I thought this would be an achieved draw. I wouldn't have given this a merit. That's just I would have given a merit for the next part. But anyway, look, we've got this here so far. Now we know that f dash of k, because the gradient at k is equal to 0. So we can actually put this as 0 is equal to 3 sine k squared cos k 3 over 2 minus sine k to the power of 4 times a half cos x, no, not xk, to the power of negative half. Now how the hell did they go from this line to the next line? Six sine cos x squared. Okay, so it's alright, Abysm. Let me know if you guys are okay up to this point now. All I've done is I've put f dash of k is equal to 0. Let me know if you guys are okay. Give me, I don't know, what do you like? Just say continue please, or no questions or whatever, and then I'll carry on. Anonymous, it was sent by good old H up the chat channel. He's someone that sent it. Cool, so we can rearrange this now. So I'm going to bring this entire minus thing across to, where should I do? How should I do this? You got up to that. I'm going to move this across. I just want to see what happens, right? So if I go sine k 4 times a half, I think I've got something here, folks. I think I've solved this. Is equal to 3 sine k squared cos k to the power of 3 over 2. This is actually not bad. So are you guys okay with what I've done here? I've just brought that whole minus thing across. So I brought this entire thing to the left-hand side. And by moving it to the left-hand side, it gets rid of the minus and it becomes positive. Okay, next, we're on to something here. I'm going to get rid of the 2 there. And I'm going to write this as sine k to the power of 4 times 1 over cos k to the power of half. I'm going to do this extra step for you guys because I know this is quite a lot on at the moment, but I can see what they've done. So done that bit, I've gotten rid of that negative half into positive half. Next, I'm going to do sine k to the power of 4 is equal to 3 sine k squared cos k to the power of 3 over 2 multiplied by 2 cos k to the power of half. What I've got is sine k to the power of 4. 3 times 2 is 6. I've got 6 sine k squared. Now cos k, 3 over 2 plus 1 over 2 is 4 over 2, which is going to give me just 2, because 3 over 2 plus 1 over 2, 4 over 2, which equals to 2. So I'm adding the powers there. Now what I'm going to do is 6 is equal to sine k to the power of 4. Now I'm going to leave cos k squared there for now. And I'm going to bring in sine k squared here. Now, I've got 4 sine k's at the top, 2 sine k's at the bottom. I can cancel it out, which means I get sine k squared is equal to 6 cos k squared. And then 6 is equal to sine k squared divided by cos k squared. And if you remember, sine over cos is tan k squared is equal to 6, and that's my proof right there. Because I think the original question asked, prove that tan k squared x equals to 6. So as much as this question looked super exhaustingly annoying, I loved it. I absolutely loved it. Thank you H for this. It's worked so beautifully. But look, I mean, like when you think about it, right? It wasn't that hard, was it? It wasn't actually traumatizing at all. Where is abysm? Abysm, is it still traumatizing, or did it actually work out for you? I actually really enjoyed that question, H. Thank you for that. But look, I think it's the whole concept is that, you know, when I saw the tan, right, I was like, I've got to get sine over cos somehow, right? And then I saw that 3 there and the 3.5, and that's how I knew. I was like, okay, the 3.5, if I move the half to the other side, then I can bring the 2 across, which means 3 times 2 is 6. So I think one thing that I'd say to you guys is this: when it comes to these proof questions, that's why I always say to people, like with proof questions, try and do them first, because when you get the proof, it's satisfying, right? It's like, I got it. You know, I can walk away from this knowing I got 8 points in this. So yeah, big thank you to H for that question. Yeah, I think so, Mel. And you know, I've not done this question before. Like the rate of change questions, I've done it so many times, right? Like this question it's such a, yeah, I'm stoked with that one. Like, I think it has to be the highlight of the day, sadly, doing this question. So thank you, H, for that. Really appreciate it. So folks, if you do have any other crazy questions like this, I think it's worth, like, I think, like, I kind of need the, like, I'm not gonna lie, like sometimes I need the, if you give it to me on the spot, like, if I have the answer with me, then it's like I can kind of understand what to do. But like, otherwise, if I was doing this question, I would have probably, like, I needed like as much time as half an hour to kind of fiddle around to try and get this question. So practice, I prefer not getting donations because I think YouTube takes like a very large cut. So I don't really need them, man. I'm happy with just the words thank you. You know, you don't even need to say that, actually. I'm just glad to help people, that's all. So you don't need to stress at all. Practice. All right, loss. You've just come at the most kind of like, I think we all just were satisfied with that proof, differentiation proof. I think that's a good time to call it a night, folks. When am I seeing you guys next for calc? I think, is it next week? When is it? Next week, Tuesday. Um, I've been meaning to ask you guys is like, look, I know this maybe towards closer to the exam, if you guys wouldn't like, if you guys wanted, like, I mean, and again, this depends on how I feel after like a level 2 stream or a level 1 stream. You know, just coming and doing like one excellence question, like really late at the night, just one excellence question, just to keep you guys kind of keep going. So let me know if it is something that you're keen. Then, you know, even like H, if you pull up like a couple of questions like that, I'm not gonna lie, I'd actually stay up at like 9:30 to kind of do these questions, because they're really just great fun. So if you guys do find something like that, let me know. But like I said, I need that. Even if you just give me just the answer, then I know that I'm not doing a goose chase. But I'd love to kind of. You can send it to me on my email, anonymous. Just put the titles. Like, I think sometimes people just send questions randomly. If you just put like level 3 differentiation and just chuck the answer in there or something like that, it just makes it a lot more easier. I'll show you what I mean by, right? Like, basically this is what H sent me. So he sent me the question, sent me the answer, and that's pretty much, that's good enough for me to kind of go with. And then based on that, I can just go, yep, this is something that's that we can easily do. No, I can't remember where I put my gear. Okay, there it is. Okay, so we are, yeah, that is definitely satisfaction before bedtime. Mel, if you do have those complex questions, send it through. Like, you know, like we can kind of fish around and just do it. Like I said, look, hypothetically, I'm only doing questions where you guys are getting, when I'm getting pictures from. So theoretically, I don't know where they come from. I don't know. It's just you guys are sending me questions, which you're all good to go. I think we had someone come from Australia. Practice 40 hours. Where are you coming from? Oh, gone quiet. Oh, man. What time is it there right now? Famine goal. What 40 hours? Are we doing what's the goal? Oh, practice 40 hours. Which part of the States are you from? Practice 40 hours. And isn't it a bit late? Is it early or late for you? What? Practice. I actually did a SAT recently just for the hell of it, because I was kind of messing around with some questions in the SAT. I just wanted to see how hard it was. Texas. Which part of Texas? Yeah, sure, H. So what I might what I'll do is yeah, so maybe that like next week onwards, I'll see how it is. If it's like 9:30, we can, after I finish the stream, I'll just have a quick little break and then come back and try and do the like the excellence question. Amarillo, jeez, I don't even know where this is. This is cool. Amarillo. Wow, northern part of Texas, man. Like you're like from like basically this Amarillo. This is where Amarillo is. Wow, that's literally in the middle of the US. Wow, look at that. Well, there we go. We learned something new today. Come to Infinity Plus One's tutorial and learn something new. What? But wait, hang on. First off, what is the time in Texas right now? Because I'm sure this is like 3:08 a.m. What are you doing up at 3:08 practice? As you can see, practice right now, you know, it's like you're gonna take over this chat. I'm just curious. I've got so many questions to ask you. Not, I don't sleep well, so watch Matt's videos. That's incredible. We got two people doing that. Marco, meet practice. Practice, meet Marco. Marco is, how do I say it? So he is, I'm trying to think of your grades, man. Like, this is pretty hard for me to understand. I don't know what you guys do. Like, I think he would be in junior high, maybe. What instrument do you practice 40 hours? I'm not gonna lie. I'm gonna have to put like a little Instagram post about this. Got a kid join me from Amarillo. Piano all day, every day. What about school then? What are the odds, man? I didn't realize that, Marco. I tell you what, practice. I might. The closest I've come to Texas. The closest I've come to Texas. Where is it? Where is? New Orleans. I've not. Now I've been to Alabama. Went to Huntsville, Alabama, Orlando. Did the west coast of U.S. Weird thing is, I never came down Texas. Would have loved to actually visit any one of those major cities in Texas, but never got to visit. So I got to ask, practice. How did you actually even find this channel? Like, did you just kind of like look up live channels, or? Now, Marco, I'm not gonna lie. When I was in Alabama, I was singing that song all day, man. It was hilarious. But I'm curious how, like, at 3 o'clock in the morning you woke up and you're like, did you just see that there's a live channel doing some maths, or how did this happen? Marco, I spent like 5 days in space camp. If you get a chance to go, you gotta go, Marco. It's so cool. I loved space camp. I'm thinking about taking my kid there when. That's hilarious. Wait, Frost Valley, are you? I'm sure you're from New Zealand, Frosty. But practice is actually from US, and this is like 3 o'clock in the morning, and he's decided to join us. Where is what, Marco? Where is what? I gotta ask, practice. What so are you in like high school, junior high? Like, what grade are you in? How does it work? No, anonymous. He's from this place called Amarillo. It's 3 o'clock in the morning, and it's 3 o'clock in the morning for them, and he's from there. It's quite a middle of, like, yeah, right there, Amarillo. How crazy is that? It's too many questions. All right, ciao. Practice 40 hours. I don't know. Yeah, I would love to have you here another stream, practice. I need to practice. Pop in anytime. You need to come and have a chat, man. We're always curious to hear stories. All right, guys, that was random, but guess what? That's us today. I will see you guys so I'll check in on Sunday. All right, like see how it is. If it's good, I'll just kind of drop in at 9:30. Just pop in at 9 o'clock just to see if I'm gonna do something at 9:30. Then I can just switch over straight away. Yeah, no, Grace. I teach year 10s across at Ormiston Junior. Space Camp Huntsville, Alabama, Marco. I'll send you my video. Hold on, let me just find it. Oh, actually, no, you guys can look at it. So, Marco, if you actually head over here, right at the bottom, there. Have a look at that video, Marco. That's pretty much what I did for the whole week. It's good fun. Yeah, thank you, Anonymous. Send those new questions in. What, the space camp or the kid practice? All good practice. It's all good. Like, just come in, have a chat. I have like a stream every 5 days. 5 days a week. So no, I did the Rocket Lab one tech gaming spot. I spent like 2 days at Rocket Lab. That was great fun as well. Marco, I actually did a simulation and I was the flight commander, which was so cool. I kind of had to look after 14 of my crew and bring them back. Stacy, I don't know. Like, I mean, last time I did it, I had like, I think maybe 3 kids came, so it was like, and then I was like, oh no, I probably wouldn't do it. But I did think about it. Botany library was what I was thinking. Community room, is it? How to book? Yeah, like, see, they have a showcase room, focus room. It's all booked out. That's the problem. Oh no, Sunday 5th of November. Sunday 12th of November. East Coast, Jesus. That's yeah, I've got to book the rooms, so I don't know. I thought about it, and then I'm like, I didn't really bother with it. So Manariva Library has been. I think Manariva Library is available. That one is always available on Manariva Library Community Room. I mean, it was a massive room, right? Like, I basically got given this entire room here, and I had like 3 kids sitting here. That was good fun. What is it? Nah, it's all booked out except for that Saturday 11th. Yeah, nah, I thought about it, but then I was like, too much work. That's why I never really bothered with it. But if people are keen, I mean, like, I don't mind. I could easily do one, but I guess it's easier online because then people can just rewatch and do it again. So yeah. But anyway, guys, look, late in the night, I will leave you guys to it, and I'll catch you guys. If you pop over around 9 on Sunday. Let's see if we've got time. If I'm feeling, especially after the game, if I'm feeling good, then we'll probably do another half an hour of excellence tutorial. Yeah, just one question, nothing serious. By the way, I also wanted to mention to you guys, where is she? This is one of my good mates. She is also doing live streams at the moment, and she's doing just 1 merit question a day. So she started doing it about last week. I went to see her at Westlake Boys, and since then she started doing 1 merit question every day. So go throw her a subscribe, and of course try and get to those 1. I know it's only 1 merit question, but it's still practice is practice. So you guys can actually get some more practice there as well. All right, till then, see you later. Have a good one, and yeah, good luck to the ABs on Sunday. Bye, guys.